Hi everyone, welcome back. Now we're going to talk about end behavior here. So this is mostly easy to draw. And so when you're thinking about end behavior, you should think about two things. So you need to think about the degree. You need to think about whether it is odd or even. And you have to think about the leading coefficient, which I'll just abbreviate LC, and you want to know its sign. So let's look at some examples here. There we go. So let's look at an greater than 0 and n is even. Those functions, whether what goes out in the middle doesn't matter. What end behavior does is talks about as x gets really large, goes to infinity, or x gets really small, goes to negative infinity. And what this for this type of functions, they will go up to the right and up to the left. So kind of the ones you want to think about x squared. Think about how x squared looks. X squared is a parabola that opens upward like this. So that's how you should think about these type of functions. And something I saw once a long time ago says that for this type, you should want to think of a person standing and they're raising their arms to the left and to the right. And that's for when the leading coefficient is positive and n is even. So what happens if the leading coefficient is negative? So if we have a of n less than 0 and n even, well then our graph is going to look like this. Well, we don't know what happens in the middle, but we do know that we're going to go this way and this way as we go towards infinity, and we don't know what happens in the middle here. You know, it could be that behavior, it could be anything more complex. And the way you want to think about this is think about the graph of f of x equals negative x squared, which looks like this. Let's give myself a little bigger graph. And the graph of x squared roughly looks like this. And again, we want to think about, if we're going to think about a person here, the kind of our rule says that the person's arms are going down. So that would be the leading coefficient negative and is even case. Alright, so what happens if an is greater than 0 and n is odd? Well, then we're going to get a graph, and it's going to go up to the right and down to the left, and whatever happens in the middle, we don't know. They can do a lot of things, as long as they're polynomial. What you want to keep in mind is the function f of x equals x cubed. And that looks like this function right here, and notice that we're going up and to the right and down and to the left. And so in terms of our person example, you're going to think of a person with an arm going up to the right and one going down to the left. Probably not so exaggerated though, something like that. So someone raising their hand up to give a high five, for example. And then when the leading coefficient is less than 0 and n is odd, then we're going to go up this direction and down that direction, and we can have a whole bunch of different behaviors in the middle. And again, your typical example you want to think of is f of x equals negative x cubed, which looks like this. And so we went up and to the left and down and to the right. And then if you want to think about a person, you know, and this time they're giving a high five with their other hand. It's back. Let's see. There we go. And so really notice that it's just the degree and the leading coefficient that determines all this. So if I give you an example, find the end behavior of f of x equals x to the 26, the negative 3 out front, plus 1. Well, we don't know, or let's add more terms, plus x to the 10th minus x to the 7th plus 3x plus 4. Well, this is probably going to be something really horrible, but one thing we will do know is wherever the horribleness is in the middle here, it's an even function, so our behavior is going to go down in this direction and down in this direction because we have an even term with a negative coefficient. So this part we don't know, but we certainly know what these two parts are. So that's it on my discussion on end behavior. So next up, we're going to move on to the next section and start talking about the division algorithm. See you then.